What is going on, guys? Mr. Allen here. We're about to start some rational equations. You might be like, bro, what the heck is that? It's that right there, man. We're dealing with fractions, bro. Fractions. I love fractions. It's one of my favorite F words, along with factoring. Okay, so let's continue here. We've got ourselves graph f of x equals 1 over x. This is our parent function for rational functions, right? The most basic of basic rational functions. Now, I have a t-chart set up here with a bunch of x values. And if we plugged in -4, I'm just going to get -1/4. And if I plug in -3, I'm just going to get -1/3. I'm just going to get a bunch of fractions. Let me fill that out. Now let's pop back to that 0 right there. What happens when I plug in 0 into my function here? I'm going to have 1 divided by 0. Can I divide by 0? Ain't no way I can divide by 0, dogs. That's a no-no. All right, so it is undefined here. Okay, it's undefined there. Now that's going to show up on the graph. I'm going to show you how that works. All right, now let's think about some other numbers here because I just have a bunch of fractions, right? That's unfortunate, you know? But what if I did this? What if I did this? What if I were to plug in, say, 1/2 for x? If I plugged in 1/2 for x, 1 divided by 1/2, it's the same as multiplying by 2 over 1. So I'd get 2 for my output. The same would go if I plugged in -1/2, I'd get -2. And then what if I did 1/3? Well, if I plugged in 1/3, then I'm going to be multiplying by 3 over 1, giving me +3. So as I plug in fractions, I'm going to get a bigger and bigger number, right? Fractions being between 0 and 1, right? Not all fractions. Okay. So let's start plotting some points, shall we? I think we shall. So at -4, I'm at -1/4. So right down here. And at -3, I'm at -1/3. So I'm going to come down a little bit further. And then I'm at -1/2. And then I'm at -1. So we got this little bit of a curve going. And as I said, if I plugged in, say, -1/2, I'd get -2, right? I just didn't write it all down there. So I'd get -2 at -1/2. And then I'd get -3 at -1/3. So we can see this little curve that's happening here. But as we get close to 0, or once I get to 0, I can't do that because I'm going to be undefined. So I'm never going to quite get there. Let's take a look at the other part here, the positive part. So at 1, I'm at +1. At 2, I'm at 1/2. 3, I'm at 1/3. And then at 1/4. So just keep getting closer and closer to that x-axis there. Then at 1/2, I said I was going to be at 2. And at 1/3, I'm going to be at 3. So we kind of see the same thing happening there, reflecting over, this line right here. Very interesting. Very exciting, in fact. I do enjoy that, yes. All right, so let's connect some dots. It's one of the best parts of graphing. Now, I can't get to 0, right? So there's got to be something going on there. So I'm going to do this. I'm going to graph like this. Okay, boom. And then I'm going to do the same thing up here. Connect these bad boys. Oh, yeah. Woo, beautiful. I'm pretty proud of that rational graph right there. I'm very excited. Okay, so what is happening at 0? Well, no matter what, no matter how close I get to it, right, I'm not going to get 0, right? I can't plug in 0. And as I get closer and closer to 0, as we get like 1/3, 1/4, maybe even 1/10, if I plugged in 1/10, I'm going to get +10, right? The numbers keep on getting bigger, either bigger going up or more negative, right? So that graph just keeps on going up. This guy keeps on going down, but it never quite gets to 0. What's there is what's called an asymptote. So we're going to put this dashed line there. It's saying, I ain't going to cross that. I ain't going to touch that, okay? Never cross it. Never touch it for the vertical asymptotes. Horizontal, you can cross them. We'll get to that another time. I'm getting ahead of myself. All right, so then we also have what's called a horizontal asymptote. And this guy right here is also going to be a dashed line. It's horizontal at y equals 0. This guy is going to be, its equation is y equals 0, and this equation is x equals 0 right here. Vertical is x equals, horizontal is y equals. Woo! Man, this thing is loaded with dope stuff. So why do we have an asymptote at 0 there? Well, no matter what I plug in here, there is no way for me to ever make this function equal to 0, right? The output will never be 0. So we show that by throwing an asymptote in there. Hey, man, it's never going to equal this. It's not even going to cross it at any time for this one. So yeah, there we go. All right. Very basic rational function, but you might be a little overwhelmed because there is so much going on. All right, practice makes perfect. Okay, so now end behavior. Let's talk about the end behavior. What's happening on the ends here? Well, as I go to the left here, my graph is approaching that 0 value, right? As I go to the right here, it's approaching 0 as well. It's actually approaching that horizontal asymptote. So horizontal asymptotes we associate with the end behavior there. So as x approaches negative infinity, f of x approaches 0 for this particular graph. And as x approaches positive infinity, f of x approaches 0 once again, right? Going over to that side. Now, what about the behavior near our vertical asymptote? We said this is a vertical asymptote here. What's happening there? So we actually got two different things going on, right? On this side, it's going to positive infinity, and on this side, it's going to negative infinity. So as I approach this asymptote from the right side over here, I'm going up. As I approach it from the left side, I'm going down. So check this out. There's some fancy notation. So as x approaches 0 from the left, that little negative there means from this side right here. So as x approaches 0 from the left, f of x, what's it doing? It is going down to negative infinity. So that negative, notice that's up in kind of like in the exponent spot almost. That's a notation to say from the left. Then as x approaches 0 from the right-hand side, so on this side, what's happening? It's going up as it gets closer and closer and closer to that asymptote. So f of x approaches positive infinity as it approaches from the right. Beautiful. You know, there's one more thing, though. One more thing that I want to do I think is very important with any graphs. Let's talk about our domain and our range, dogs. Domain and range. All right. So my domain, my x values, right? Are there any no-nos on this graph, right? We've dealt with polynomials before where it's just like everything. It's all real numbers. But now we got these dashed lines, and we said, hey, man, I can't plug 0 in here. It'll be undefined. So I can plug in any x value I want except for 0. And the way we can write that, there's a few ways to write that. The most shorthand way is x cannot equal 0. And sometimes people will write it like this. We could say x equals all real numbers, but x cannot equal 0. Okay? Or you can use inequalities and other things like that. I'd say the most basic and accepted version is this guy right here. Clear, to the point. It's assumed in this one that it's all real numbers, but we just can't equal 0. Some mathematicians might frown upon that shorthand, thing, but hey, man, I'm a busy dude. I'm busy dude. Time is money, you know what I'm saying? I want to go shorthand. All right, range, all my y values here. Are there any outputs that don't exist? Well, as we said, 0 does not exist here for an output value. So we can do the same thing, y does not equal 0, or you can do the same thing right there, or you can use inequalities. For example, inequalities, I could say y is less than 0, or y is greater than 0, right? That'd be another acceptable way. So we'll go over some notations like that in another video, but that's about it for this one here. I know it was loaded. That was a ton of information there, but you're gonna love them. You're gonna love them, dogs. All right, have a wonderful, wonderful day. America, freedom, rock and roll, Costco. Riverdog Jenny on the gram, Mr. L Math on all the different socials. Make sure you like, subscribe, or whatever people say on the internet. See ya.